Greetings from Indian Institute of Technology, Kanpur. I am S. Sundar Kumar Iyer. I am a faculty member in the Department of Electrical Engineering. So let me start off first with a disclaimer. And the first time I'll tell a little bit about it. Next time I may just flash this. I want to make sure that everybody realizes that this is an academic exercise. So I have used material from various sources, and to the best of my ability, I have tried to acknowledge where it is coming from. And these lecture slides are meant only for the students who are watching the video, and it belongs to NPTEL. So right now, I would request that nobody please put it in any public site. And if at all you need to use it for something, please take permission from NPTEL. If there is some error in not acknowledging some work, please inform us and I'll be happy to make the correction. So let me start off first by acknowledging and thanking my teachers. I was a student of Professor K.N. Bhatt at IIT Madras, and he was the one who taught me semiconductor device processing. And he got me started, and I did my MS there, and in his labs I learned some practical aspects of semiconductor processing as well. I also want to thank Professor Nathan Chung, who taught an excellent course at UC Berkeley on IC fabrication, and I still remember all the wonderful things that ideas that he told us, and I'll try to share it as we go along in this course as well. So I thank them. I also thank many other people from whom I have learned. Of course, fellow students who work with you in the lab or in your research, and then co-workers both at industry and later in the academia. So I thank all of them, and a lot of what I am telling is built on what I've learned from various people, various sources. So let me start off by just giving a broad outline of what to expect in this particular lecture. First of all, I want to just say how pervasive electronics is. Probably all of us are aware of it, but maybe just a reminder of that. But therein lies the motivation for this course and what we are going to focus in this course. So after that, I would also go through the topics that we discussed in the course in a broad level. You have this information, but just to give you a feel for what is printed means. So let's get started. First of all, there is no one watching this video who is not influenced by electronics. The very exercise of watching this video means that you're using some electronic gadget. And not just that, our lives are now pervaded with so many electronic items, from watches to televisions to refrigerators which have controls, all sorts of things. So, and there is a whole area of consumer electronics which is there. And not just that, over time, this electronics has become more and more sophisticated and smart and intelligent. In fact, there are smart watches which, when you wear, it tells you what your blood pressure is, and it tests the sweat glands and gives you details about your health. All sorts of things are available today. And of course, the latest among the latest that has come into the human life are the smartphones. These are amazing because they are not just phones. There are all sorts of things associated with them, including of course, the communication part is one of them, but we have lots of other facilities, including cameras and so on. So what is amazing is the amount of power an individual holds in his hand today. What he or she holds in his or her hand today is far more than what was even imagined a few decades back. And this is all because of electronics. And what is most interesting is they are all affordable for many people. Of course, there are still segments of the population who may not be able to afford the most sophisticated electronics, but a large fraction is increasingly able to afford all of it, some of the most sophisticated electronics. But the mystery is, what is it that allows this high performance to be available to everyone at a low cost? One of the key components, and I would say one of the basic component, is the manufacturing or the method adopted for manufacturing these electronic devices. And that makes them affordable to everyone because of the scale in which it is done, And not just that, the fact that with time they are becoming more and more sophisticated. So this is part of the consumer electronics that probably all of us are familiar. There is another dimension of electronics which many of us might not often think about, maybe we all know about it, these supercomputers. These behemoths which sit in a room of a large size, sometimes whole buildings are occupied by a single supercomputer. So I have given here one example of L-Captain that is present in Lawrence Livermore Laboratory. Is one of the fastest computers today. And in fact, it is able to do 2 exaflop per second. What is exa? 10 to the power 18. And flop is, as I have mentioned here, floating point operation. And these are typically double precision 64-bit operations. So this is mind-boggling, because if you are talking about 2 into 10 to the power 18 operations, even if all humans, which is roughly 10 to the power 9, 10 to the power 10, let's say 10 to the power 10 number of people in the world, if each person is going to do one floating point operation calculation, that means each person has to do 10 to the power 8 floating point operations per second. That's mind-blowing. And that's, of course, a human can never do that. Even one floating point operation per second itself is a challenge. That is the power of these computers that we are talking about. And it's not just supercomputers that are present far away, but there are also supercomputers available in India today. In fact, I have given as an example, and there are many supercomputers in many top institutes around the country. Here I'm talking about Param Sanganak. This was set up in 2020 as part of the National Supercomputing Mission. Okay, so this also has significant power, 1.6 10 to the power 15, that is petaflops, 10 to the power 15 petaflops, and this is used for high performing research around the campus. So supercomputers are a reality today, and many of us may not realize these are the ones that drive artificial intelligence, that help us many times with the navigation that we have in GPS, and of course solving a lot of problems which require intense computation, including finding solutions. For example, vaccine solution used supercomputers in order to do the research fast and zoom into the solution fast. So now, what is it that allows this super high performance? Again, it comes to the chips that are made, which are able to work so fast. And once, of course, you have the chips in place, the other things come together, including software and the way of putting systems together, and that goes forward. So you can see that electronics is there all around, and not just all around, they are playing a very significant part in modern human life. So if I may just give an overview what electronics is about. First of all, the circuits are designed, a whole team that goes and designs based on what is to be made, and they build it on a silicon wafer. So I have a silicon wafer here. Okay, so now, and on this wafer, you make a large number of chips, as you can see. Okay, so within each of the chip, you have almost full systems sitting there. We'll discuss a little bit later also down the course on this. So you have to make this on a silicon wafer. Remember, silicon wafer is crystalline, and you can cut it into small dies. And after you cut it into dies, you package them. So I'm sure all of you have seen ICs. So this small teeny weeny one, not sure if it shows in the camera. This one is 741 analog circuits. You must have used it. These were all made long time back, and they are continuously improved. Digital circuits, 7400 series. And then we have also microprocessors. Of course, this is an older microprocessor used in academic setting, 8085, 8086, this which is used for teaching students. So you have all these ICs where you pack them into plastic packets, epoxy or whatever is the material, so that it's isolated and from the environment, and also electrically they are isolated. Once they are, the chips and components are available, as all of you know, and many of you might have done in projects as well, you put them together in a PCB, printed circuit board, and you build a whole system around it. And using these PCBs, you can build larger systems. So even this phone that we have, inside that there is a PCB which has components which are soldered there. But what is at the root of all this? If you look at it, it's the devices that are made. So this IC manufacturing therefore is the foundation stone, you can say. There's a lot that goes into it from various people of various fields, as I will be showing shortly, but clearly that is needed in order to build the electronics. And this is one of the things that we will be emphasizing. This is the main focus of this particular course, how to build such circuits, the basic introduction of course. And we will also touch a little bit on the packaging side, not much but very little. And today packaging is becoming increasingly important, and that's the reason I think it's important to discuss this as we talk about chip fabrication, IC fabrication itself. Now it should be noted, this IC fabrication of course is sophisticated, it's wonderful, but it doesn't come at a low cost. You have to pay a lot of money to build it. In fact, a state-of-the-art IC fab could be upwards of 20 billion US dollars. And it can be really costly to, first of all, to set it up. But once you set it up, you have to make sure it's run very, very professionally, continuously. Even some breaks and all are not allowed. No power outage, nothing. You have to make sure it's continuously running. So it's not going to be that easy to set it up. But yet, there are lots of people who are trying to do that around the world, and including in India. And not just that, besides the hardware to set up the fabs, which are small cities in itself, if you look at it, you need skilled manpower. You need people who will understand what is being done inside the fab. So that is the goal of this course, to get you started towards becoming part of the skilled manpower, those who are interested in this area, to be part of the ecosystem of fabrication of semiconductors. So if I give an overview of where this whole thing is in the economics of things, so if you look at it, we have materials with which we build devices, and once the devices are designed, you actually process them and build them, and usually you try to build them as integrated circuits. There's a reason for that, as we will see in the next lecture. And then with those we build circuits, and with the circuits you build a system. Usually this whole bunch of activity comes under electronics, and sometimes intruding into the materials, and sometimes intruding into what is called the computer science and engineering part. And then on top of it is computer science, finance, business, and so on. What is interesting is, for every device you have, you can build many, many circuits. For every circuit you have, you can build many, many systems. So you have an adder circuit that you have designed. You can replicate it and build many, many systems. And for every system that you design, clearly you can have a lot of software that will end up being developed. So you can see economic activity actually keeps increasing as you go up the ladder. That being said, one should remember that it's built on the foundation of something that is has to be very solid. And that's why the lower you go down, you have to make sure you understand things better and better. And that's where the sciences, physics, chemistry, all that becomes extremely important, and materials has to be very well understood, devices have to be properly designed, and also ICs have to be fabricated. So now, today if you look at it, whole electronics, this market share is pretty large. In that I have tried, of course this is a little subjective in the sense, depends on how you try to divide the market. So I just looked up what the market size is for semiconductor processing and integrated circuit market. So in 2024, it's more than $500 billion, so $681 billion US dollars. And in 2025, it's expected, in this current year that we are in, it's expected to go up to 755 or so. And by 2032, it's going to be $2 trillion market. It's expected because with all the type of electronic activities, including AI and all that's proliferating, you need more investment and more activities in semiconductor processing. So clearly this is an important area. But why is it important for us in India? Besides what is important around the world is also important for India, but it's particularly important for India because if you look at it, our market currently is 40 to 50 billion. And as we become more prosperous, this market is expected to become large. But even within that, almost 50% has to be imported. That means we are losing valuable foreign exchange. And also, there is a huge market out there, as we saw, and we are only able to export only about 3.6 billion US dollars worth of electronics to the outside world. So clearly, two things. One, we need to make sure that we are able to manufacture for our local needs to be self-sufficient. And not just that, we also need to make sure that we are able to capture the markets outside, support the world, mankind for various activities. So that is where it is. So in 2030, the projected Indian market is about 100 to 110 billion, more than doubles in the next 6 years, in the 6 years since the data is given. And we are expected to increase almost 25 folds, between 20 and 25 folds of the export. So that's expected. Depends on how things pan out, how we are able to manage what we are doing. And that being said, the good news is we have a India semiconductor mission, which is actually working it. So money has been invested in it, and they are already at their job. And there are lots of allied programs that are there, which are helping in ensuring that the production activities of semiconductor fabrication and allied activities are taken up. And it is interesting to see in the last 2 to 3 years, a lot of fabs have become a reality in India. In fact, there are many international companies and many local companies collaborating with international companies that are set up across the country in various states, Gujarat, Assam, Andhra Pradesh, and so on. There are lots of in Odisha. So some of these are conventional, traditional VLSI-based digital VLSI chips. Some of them can be a little different type of technology, but they are all coming under semiconductor fabrication technology. So when all these plants are coming up, of course, money is needed for investing and setting up those fabs. But what is even more important, and that's what many people tell me around the world whenever I talk to them, it's the manpower that is most critical. And that's one reason people are anxious to even hire manpower from across the world to run their fabs. So we in India too will need to develop skilled manpower to help in the manufacturing of semiconductor ICs. And this is the motivation for this particular course. So given this motivation, so let me quickly tell you the topics that I have curated for this particular course that will be continuing henceforth. So first I would like to give some introduction. Of course, what I did now is also part of that introduction, but I will be giving you the trends in the IC and the scaling of devices, because scaling of devices is one of the key things what is making sure that prices are kept low and also performance improves. Both of them go hand in hand. There are challenges, of course, and I will try to highlight wherever possible the challenges. The process integration to build the ICs. Now, it's not about building discrete devices, but putting together lots of them on a single chip. Of course, there are some newer algorithms coming up by connecting multiple chips, but the fact remains that in a chip, as much as possible, you want to put as much electronics. And that is the key thing about process integration. We'll take a brief peek into that. This is an introductory course, so we'll just take a brief peek so that one can build on that for those who are interested and take it forward. So we'll talk about planar process, which is the core, which seems to be the one that is likely to continue for the coming decades. Then we'll talk about some topics which I think somebody who's going to work in the semiconductor industry needs to have some familiarity, whether it's vacuum processing or about clean rooms, some parameters that are needed, and plasmas that are used. I'll just give a brief glimpse, some introduction. Of course, each of these topics are vast, but my idea is to give an introduction that to these topics and to make people aware that they are critical for our semiconductor fabrication. Then we will move into the fabrication aspects of the devices. First, we will of course start with the substrates. Traditionally, silicon substrate has been the mainstay. I'll spend some more time on that. And that's one place where India as a country also is likely to invest in the coming years, more of it, so that we are able to at least some of the local needs can be met with that. And some other types of substrates, which I'll just touch upon briefly, unconventional substrates, especially for those who may be going to research, or in the coming decades, these will become more important. Then we'll go into the various unit processes that are needed for making this process integration. So these unit processes, typically you can classify them as additive, of course patterning, which is the way which decides what remains and what should not remain. So after the additive, you pattern and then remove whatever you don't want. So this is the basic thing. So there are various types of basic processes that are there. Of course, there are zillions of processes, but I'll talk about representative processes, which may be helpful in understanding the basic process flows, and also newer processes can be learned with an understanding of these basic processes. Finally, I'll conclude with some topics which I think is very important and all engineers should know, I would think. Statistical quality control, design of experiments, some glimpse, very brief discussions, and at least pointers to know what it entails. And then finally, I'll talk about the future trends that as I see it in the area of semiconductor processing. Some aspects like stacked FET and other things which are becoming more and more mainstay in the electronic industry. So with that, I'll conclude this introduction session by talking about the takeaways of what we discussed in the last 20-25 minutes. Electronics clearly pervades modern life, and in fact, even if you try to, it's difficult to get away. Nowadays, you have retreats where people are asked to keep away all their cell phones and all electronics. So it's come to that level that you cannot even get away in your daily life. So it's part of our life. We have to accept it and we have to learn to deal with it. But the mainstay for this is actually semiconductor processing and ICs, which is the building block. The whole world, and certainly India being a big fraction of the world in terms of population, we also need to have fabs where we can build stuff which we need. And the fabs that are being built in India and around the world, they all need manpower who can understand what is needed so that they can come up with even better and better processes and come up with novel environment-friendly approaches and so on. So that is the purpose for which this course is being offered. And I would like to discuss topics which I feel would help a person to get started. What I am expecting is, after going through the course, you would have a general feel of what semiconductor fabrication is all about, and whichever topic is holds your fancy, you can pursue that even further in greater depth. And in fact, any of the topics, there is a whole ocean out there in which you can innovate, contribute, and make a very good contribution to society. Okay, so thank you.